Hey, thanks everyone for joining us for another Charlotte Snowflake meetup group. Carolina's Snowflake meetup group. I'm thinking Charlotte today, but all about the Carolinas and really all over the world. Everyone's completely welcome to join our Snowflake meetup group. So tonight we're going to be talking about Snowpark for Snowflake. It's a great topic. This is one of the latest topics to come out of Snowflake. They've been making lots of advancements with their Snowpark integration. We've even seen some new things in the new Snowflake UI. So let's get going here. Well, if you've attended one of our meetups before, then you know that we do record these. We put them out on our YouTube channel for everyone to take a look at, maybe rewind something, and definitely share some of the great content that we've been providing the world here. Tonight, we're just going to walk through Snowflake as a refresher. We're going to talk about what Snowpark is and maybe what it isn't. As usual, we'll talk about some of the use cases and benefits of working with and implementing Snowpark. Got a little bit of a demo for you all, and then we'll open it up for discussions and questions and talk about some of our upcoming events. And as always, everyone's input is welcome, especially as we are looking for topics and guest speakers for some of our upcoming events. So just diving into it a little bit, what is Snowflake? I think most folks at this point know what Snowflake is. It is really that end-to-end platform for ingesting and allowing data consumers to access data through a myriad of paradigms, handling things like data integration, streaming, handling some aspects of transforming the data, and then of course, providing that layer and that baseline for data analytics. Lots of great use cases for ad hoc real-time operational reporting, KPI development, and so many, a myriad of other things related to data from ingestion to output. So when we talk about Snowpark, so Snowpark is that latest and greatest framework from Snowflake that adds that developer layer for Snowflake customers so that they can incorporate and develop in familiar data sciencey tools, incorporating legacy and very well-known SQL syntax with Python, Java, and Scala, so that they can really ingest lots of data sources and then, of course, make sense of their data, again, following data science best practices, but also incorporating other types of concepts such as DevOps and so forth. And so we're really excited to talk about this topic tonight because there's so much that can be done with this tool. I think we're only scratching the surface on what Snowpark's going to enable not only data scientists, but data enthusiasts and data modelers to accomplish all through the single platform, if you will, of Snowflake. So if we focus on some of the use cases and some of the overall benefits of Snowpark, really allows the ability to do custom data processing, be able to build, and extend, if you will, custom applications. It's definitely ripe for machine learning applications. We talked about DevOps, data ops, and of course, if you've been reading some of the buzzwords lately, there's also the concept of ML ops for machine learning operations. And so intertwining these into the Snowflake product, really, I think that gives us this Snowpark concept that we can leverage so that we can, of course, leverage other things like data integration and handle very complex data transformation. So again, data science developers are going to feel quite comfortable in this environment, or rather working with this framework, as you'll see here in the demo in a few minutes. So benefits, they might seem to be very self-explanatory. And I think that they are, because the benefits that come out of using Snowpark are going to be vast, because you're combining the compute and the processing capability right? The complete scalability of Snowflake with this ability to do data science work through Snowpark. And so you're gonna be able to run your code directly inside of Snowflake, accelerate your workloads, handle very complex workloads, obviously. And that's gonna enable your data science team or your data team in general to develop in a much more software development, DevOps, centric type of paradigm, which is becoming more and more the standard for working with data. And that includes everything such as having your code in a Git repository and so forth and so on, right? So this is taking that traditional DevOps and data engineering standard and really applying it to, in this case, into Snowflake. We think it's going to enable better partner integrations. If you've looked at some of the things that Snowflake is doing with their partnership with Anaconda, and then of course, again, with open source libraries, the partnership with Anaconda, being able to have some of those curated libraries there available for you. So data teams that might be a little newer, might be more, you might have a more novice level team. This is going to allow those data team members to really find a nice clean path to working with data in this capacity as they align that with Snowflake. And of course, one of the other benefits is you don't have to actually go to another tool, right? So there's other tools that are out there that, talk about Spark and some other, sort of fast workloads that you're working, especially with Python. And now you can do that all within Snowflake. So that's actually really cool. All right. So at this point, yeah, unless there's any questions, we'll turn it over to Anupam, who's going to walk us through a little bit of a demo. And Anupam, you're gonna kind of set up the demo, what you're going to go into, what you're going to accomplish, right? And then after that, if we have any questions or we want to open that up, we'll definitely dive into it then.
Thank you, Christian. I'll take it forward from here. Let me just share my screen. Okay. So taking forward to what to the great introduction that Christian just said for us. Basically, Snowpark kind of lets you extend your capabilities in Snowflake and lets you play around and give you more features that you can extend your existing data pipelines. So just to give you a quick sense of the various flavors that you can have with Snowpark. So what you have right now in front is the demo that I'll quickly start and talk about is using the Snowpark libraries in Python, and then kind of explain some of the functions, and then walk you guys through a quick linear regression implementation using Snowpark. That how would you go about setting up a linear regression training and then testing the model and running the model completely using Snowpark. But before I go into that depth, I just want to kind of emphasize that there are two ways of kind of working with Snowpark. So number one is that, which you see right now, is that you import the Snowpark libraries into some form of a notebook, and then you work on the notebook using Snowpark. Or the other option is that you completely work out of your Snowflake instance using something called as Snow Sheets. So in Snowsite, you have the option to create Python sheets. So on the left, once you enter Snowsite, you click on left and you can create something called the Python worksheet. And when you click on the Python worksheet, it will take you to a page which is going to look exactly like this. But fundamentally, from a library standpoint, whatever that you can do in a notebook, you do the exact same thing even in your Python worksheet. You've got to import the same Snowflake.Snowpark libraries and the same functions, but the only difference is the medium. In this case, you can execute this as a worksheet in Snowflake, and for the other one that we'll walk through is basically using a Jupyter notebook. And before I go to the notebook, just a quick touch on the worksheet here. As you look at the top, this looks something very similar that you have in your classic console, where you can choose your database and your schema. That is fine. But what you see here are the list of packages that come pre-installed. So these are the pre-installed Anaconda packages that come predefined that you need to work with them. And you've got your different settings that what will be your main handler, and then what's the output back from your main handler, and so on. But before, I think we'll probably have a different session to kind of cover Python worksheets. For today, I'll just go back to my notebook and talk about using Snowpark from a Jupyter notebook. So first thing is that you've got to import your snowflake.snowpark libraries, and then there are some predefined functions, such as which I'll talk as we go further. But then as you look at the code, there are some predefined functions that you need to import. One of the most important method that you've got to import is a session. So if you don't use a Python session using Python worksheet, you'll have to start a session from your notebook. And that's precisely what we'll do first. So once we import the libraries, these are the connection parameters that you would use to kind of connect with Snowflake. For this demo, we've already set up that predefined, and we'll use the connection settings. But for you to kind of set up your settings with Snowflake, you'll have to pass your account, which is your account number, your username, your password. And you've got other optional features like what role you want to log in with, what's the default warehouse database and schema, and so on. So people who've used the Snowflake connector library would feel at home with this concept because it's very similar to that. And once you connect, you've got to create your session. So you get an instance of your session. And if everything goes well, you can do a quick test to say session.sql. And as you see, the SQL is a predefined method that comes with the snowpark.session module that you have here. And just like we do in Snowflake, we set the database, we set the warehouse, and you would get a success or an error message back from this method. So in this case, it says that whatever statement you've run, it says that statement has executed successfully. Similarly, you can run other DDL operations like, so let's assume that instead of running database or warehouse, we want to create a table. So we do session.sql, and we run the SQL that we run in Snowflake, and you would see a success message that comes here. Let's go on to insert some values, and then now let's do a select using the .sql method. Now you see that one finer difference is that this method here, .sql, did not have a .collect at the end. And when you don't have a .collect at the end, and if you just run that method, it just gives you the type of the object that gets returned from the .sql. So to emphasize on this concept that what you get back is a Snowpark data frame. And I'll talk about what exactly the Snowpark data frame, but the idea that if you remove the collect, you would get the type of the object which comes back. But if you do a collect, you actually get back the response from your SQL. So make sure that if you're trying to talk to Snowflake using .sql, have a collect at the end to get the results back from this method. Now, as I said, what is the difference between a Snowpark data frame and the other data frame that we're used to? So we usually work with the pandas data frame, and people who work with data frames in pandas, it's a very similar concept, but you still have to convert your pandas data frame into your Snowflake data frame if you want to use a standard pandas data frame. So I'll explain what that means. So let's assume that we've got a table called sample product data that's already pre-created in Snowflake. So we can read the data by calling the table method from a session object. So we say session.table, and then you see there's a method called .show. And this is something which is applicable with the Snowpark data frame. And in your pandas data frame, this would be something like .head. So these are the minor differences. And if you try to do a .head here, it would error out saying that it does not have a method called .head because .head will work with a pandas data frame. So you can actually convert your pandas data frame into a Snowpark data frame. That's exactly what we've done here. So if you look at this method, the df_pandas is a pandas.core.from data frame. And if you look at the type of df_table that we got up here, it's actually a snowflake.snowpark.table that we get back from this particular method. So all you have to do is say df_table to .pandas, and that will convert the Snowpark table into a pandas data frame, and then you can work around and do all your processing that you could do with a pandas data frame. So if you're comfortable working with pandas data frame, you can take the input from Snowpark SQL into the table which comes back, and then convert that into a pandas data frame by doing it to pandas. And that opens up flexibility for you to work in Python. There are multiple ways of creating data frames in Snowpark, and I've just shown some of them. But if you look at the Snowpark documentation, they've probably given 6-7 different ways of creating data frames, Snowpark data frames in Python here. So one way is something that we touched upon earlier, is that we call session.table, where we just specify the name of the table that will return the table. The other way that you can actually run the SQL, so you can just select name from sample product data and do a show. You'll have your data frame like this, or you can actually create a structure. So 1, 2, 3, 4, the values that are passed. But for that, you'll have to call create data frame, and you've got to pass another method call it to 2_df to specify the name of the column. That's another way of creating a data frame. Then there are other ways of passing the values in create data frame, and you can specify the name of the columns in schema, another way. And then there's something called as a row, where you can import the row method from Snowpark library, and then you can say create data frame, where you specify row and map each value to the column. So they basically achieve the same result, but it's a matter of using it as per your convenience and your requirements. So before I go on to the use case of applying a machine learning example to Snowpark, I'll take a quick 5-second break to see if there are any questions at this stage before I continue. Heather, I can't see the chat. Do we have any questions in the chat?
Nope, we're good for now. Keep
Okay.
going on with that.
Okay, so let's continue with applying machine learning with Snowpark. And so what we've done is, there is this example and data provided by Snowflake Labs. This is an exhaustive example that they've given. We've taken some of the finer elements from this reference for this demonstration. But in case if you are curious about the entire demo that they have done, so as part of this demo, what they've done is they've talked about setting up stages. They've talked about setting up Snowpark, and they've also used this logic to reflect the data back on Streamlit. So it's the end-to-end solution for Snowpark by Snowflake Labs. So we'll post this in our GitHub, and as part of the session notes, feel free to reference this link. And based on the link, we've derived this example for today's session. So using the same method, session.sql, you can first look at what's the existing setup in your Snowflake that you're working on. So you can actually you see that that the current user, the current role, and the database, the schema, and the current version of Snowflake, and the current version of your Snowpark for Python version, you can do by calling the SQL and then reading it in form of a list. So you could, in fact, this is a matrix. You can look at the matrix and see what each value has. So a list inside a list, basically. And then after that, we touched upon this method .table, where we're trying to read some form of campaign spend into a data frame for further processing. So we are trying to load some aggregated campaign spend data, and this data will be used as a feature to perform linear regression and do a prediction on the revenue based on the set of features. So that's the use case we're trying to come up with, that based on the advertising spend, can we predict the ROI prediction based on our features? So we're going to do linear regression to perform the prediction for this example here. Before I go into the setup and the code, I just want to quickly touch upon that in our Snowflake instance where we are reading from, we've already done some setup. So if you see, these are public data that's given to us from Snowflake Labs that you can try at your end too. So they've given some form of dummy campaign spend, dummy monthly revenue, and so on. We've used this data for our predictions. And if you look at the code, what we've done is that we've created a CSV custom file format, and then we've created external stage to read from the S3 bucket. These are public S3 buckets, so you can access them. And then we've copied them from the stage into tables. So we've copied from copied into campaign spend from the campaign spend the external stage, and we've copied monthly revenue into monthly revenue table from the monthly revenue data stage. So whatever you see here are the tables that we've already pre-created for this demo. And one important point which I'll touch upon is that there are some stages, internal stages that we've created. So one is called dash_store procedures, where we will go and store the store procedure that we will create as part of this demo. And then dash_models are the stage where we will load the models that we will have created. So we will train a model, and then we will load the model into a stage, and we will use the loaded model to make predictions for our requirement. And then we will use the UDF to actually perform the prediction using the trained model. Just keep in mind, these are three different internal stages. And when I get there, I will again emphasize on these stages. So we read the campaign spend here. These are just some more Snowpark methods that you can see that, for example, if you want to see what query is run in Snowflake. So you see that when it tries to read the table from .table campaign spend, it's just doing a static star from campaign spend table. If you also want to see the query history, so you can create an instance history, and then you can actually specify what queries you want to track. So for example, when it says snowdf spend.show, it shows that this is the query that runs in the background, select star from campaign spend limit 10, and then it also gives you a query record. So this is useful when you want to do some form of debugging to see that what query was executed when, and it's just a mechanism to do debugging. Now, for our machine learning example, as I explained, that we're trying to do ROI prediction. And for that, our input independent variables are going to be certain features. So these are the features that we're trying to create. So, and these are various different forms of spends. So we will have some form of spend, which is going to be spent per channel per month, and then they will be spent across different channels, and so on. So for the first feature, we're just trying to find the total cost across channels, which is grouped by on year and month. So that's called the total spend per channel per month. That's a feature that we've created here. Then our second feature is nothing but it's just going to be our spend, which is going to be pivoted for our different channels that we have, which is aggregated across year and month. So we've got that across channels. And then third, we've created another feature, which is nothing but it's the total revenue, which is grouped by your year and month. And then in the end, we've just created one single table so that we have one single feature table where we can actually map our year, our month, a different form of channels that we have, what's the spend for each channel, and what's the revenue that we have for that particular month and the year. So we have all our features in one single table, and we will use that in our training below. So as we go to the model training part, so what we've done is that the first step is that we've removed any missing value. So this is people coming from pandas, but to understand that drop NA is where you drop any null missing values. We're not interested in using any form of year and month. Again, if you're not doing any form of time space modeling or any form of time forecasting, time modeling, then you don't need to really use year and month, because having year and month for non-time modeling might sometimes ruin your output and predictions. So those two columns have been dropped, and we're just trying to save those tables into a temporary table for now. So we've created something called marketing budget features, and this is what the final set of features looks like for our machine learning. Again, for linear regression, we're going to use the famous scikit-learn models. So if you look at this function that's been created to actually perform the train, without going too much into detail, but we've done the standard setup. So you've got all your models and all your libraries. You've got your linear regression model coming from scikit-learn library. You've got your grid search and your train trace split, so on, so coming from scikit-learn. You've got your feature engineering, polynomial features, and standard scaling normalization coming from scikit-learn and so on. So the first step is that we've taken our features table, we've made it into a data frame, step number 1. And after that, since we've got two kind of features here, we've got numeric features. We just want to make sure that we perform some form of feature engineering on that. So we've just tried to see if we use polynomial feature of the degree 2. So that means you would have the square of each feature along with the product of each feature as different input features for your, and then we scale the value using the Gaussian scaling formula using the standard scaler. That's done. We've tried to combine the two into a pipeline. And then we've dropped the revenue because we have to predict revenue. So we will drop it from a feature. All the features go into the list X, and our target variable, which is revenue, will go into Y. We've done a train and test split for 80-20. So 0.2, 80-20 with 80% for train, 20% for testing. And then we've done the grid search optimization. And these values are something that we will pass when we'll call the function, but we'll do it for 10 folds, standard values for doing cross-validation folds. And then this is where we actually fit the model, and then we calculate the R-squared scores for train and test, and so on. But I think this is standard. You must have seen your machine learning code, but the idea is that after you've run the code, you can actually go and put your saved model, your saved train model into the stage I was talking about as @-model. So we will use this train model later down below to go ahead and then do prediction on this model. After that is done, so we're just trying to call the same model with our features given these different parameters I just went through. And then standard, you can analyze your threshold values to see what's there. Okay. Now, one important feature is that you can actually go and register this entire execution to run as a stored procedure. So what we're doing is that using the Snowpark capability, we're saying that this particular training model, that means this function that we defined here, which is the train revenue prediction model, can be called as a stored procedure. And that's what the register method would do for you. It will register your function as a stored procedure, and these packages will be installed when the stored procedure runs, and it will go and store the out. And this stored procedure will be stored in your --sprocs stage that you have. So let me show you what happened in Snowflake. So if you go and see at show procedures, you should see our procedure that is available that runs with these arguments. So it behaves like any stored procedure you have in Snowflake. So the important thing is that we've defined the procedure here, but we're registering it in Snowflake. So once you have registered that as a stored procedure, we are calling that stored procedure from session.call, where we pass a feature. So this is very similar to what we see up here, just that this is being called from Snowflake directly. That is done, you get the same output. And now once you've done the training, you have a model that is stored, it's time to perform a test and do predictions on your train model. So for that, what we've done is we've created a UDF where you can actually pass your session instance, and you can pass your train model, you can pass your features, and it would perform a prediction of the ROI for you. So what we've done is, for training, we've created some form of some values that we want to predict against, that's being passed to our UDF up here. One important point is that if you look at the two methods, which is session.addImport, that is just adding the model that we trained up there, that it knows that it has to access this particular model, and it knows that it has to add these packages for this prediction to work. So that is, you'll have to specify what models and what Anaconda packages you need to perform the prediction, and then we actually call the method to do a prediction, and the output of the prediction is stored as predicted_ROI. This is what it looks like. So we pass the values, we pass the features, and then you have predicted ROI, which comes here. Now, this we've done in Snowflake. You can actually take this UDF and call that into your some form of UI. You can call that in Tableau. You can call that in Looker. You call that in Streamlit, and you have an end-to-end working machine learning prediction model using Snowpark. Yeah, I think this is what I wanted to cover, and I'll quickly, I think I see a question in the Q&A. No, I'm only using Python. I am not using R for now. Whatever code that I've done as part of this session is completely in Python. In fact, that's a good question that I don't think there should be any form of support, at least for Snowpark. Christian, correct me, using R in Snowpark. So you could read data from Snowflake, like using Snowpark, put that into Python, and then you can use the R libraries in Python to do all of the R work that you have to do. But that'll again be like a hybrid solution for that.
Mm-hmm.
Hope if that answers the question.
Yeah, that was a good question. I think another question that might come up on Pav is, when you register that stored procedure, can you call that stored procedure then inside of Snowflake with standard SQL at that point?
Right. That's right. So I think I would want to show what the output looks like. If I can show what it's going to be here. Yeah, if you look at this, I have the output that is there.
Mm-hmm.
Okay, I will do one thing, Christian. Let me. I don't think I should be having the output which runs here, but let me try to get that what it looks in Snowflake and show what the output would look as the prediction that works in the background in Snowflake. Yeah, that's a good question. That when your stored procedure runs in Snowflake, what would that look like in Snowflake history? Yeah.
Well, I think even without showing, the question is, can you run it in Snowflake, right? Can you call that stored procedure with plain SQL? And I think you said you could, right, earlier. So yeah, it's just a standard Snowflake stored procedure object, correct?
Right.
Yes.
Right, and that's why I showed the definition also, which showed the definition of Snowflake that you have for the stored procedure.
Exactly. Great. Let me see. Heather, I don't know if you have the ability to spin up the slide deck once more. I don't think there's that many more slides there, but if you can, that'd be great.
You guys see my screen again?
Yes. We
All
see
right.
discussions and
Perfect.
Q&A.
Are there any more questions out there?
Mm-hmm. Well, even if there aren't questions, what's always interesting in these discussions is to kind of hear from other folks, what type of workloads they're working on, if they're coming from a different product suite perhaps, and if Snowpark is something that they've heard about recently, or if they're currently using it, or they plan on using it. I think it is one of the newer features coming out of Snowflake, especially with complete support now in public preview. So you've got Python, Java, and Scala. I think that's going to open up tons of workloads, especially for coders who, again, Scala, Spark, but Java in particular, where that language has been around for a very, very long time, not going away anytime soon. And just to kind of see the type of developers and the type of use cases potentially with existing code that'll really come to the forefront here. Looks like somebody's used it within DBT. Very cool. Yeah, and I think as far as one of the upcoming sessions, we're planning on doing DBT integration. I know you can speak to that more than I can, Anupam, but the whole DBT Python integration. But any other questions or comments from anyone? All right, well, maybe we can hit the next slide there, Heather.
Yeah, so we'll have some more events coming up soon, and you'll get those out in your inbox from our meetup group, and you should be seeing them come through sometime this week, I'd say.
Fantastic.
Awesome. Well, thank you guys for joining us tonight, and we look forward to seeing you next month. Towards the end of the month, we try to keep these every Monday, the last Monday of the month, but we hope to see you again next month. And please feel free to reach out in the discussion board with any topics you're interested in hearing, or if you're interested in becoming a guest speaker or that kind of thing. Like Christian said earlier, we're always looking for other people to contribute. Thanks everyone.